Okay, we have here today an interesting integral. We've got the integral from minus infinity to infinity, x squared over x to the fourth minus 6x squared plus 25 dx. Okay, to get started with it, I want to do something maybe a little strange. It's probably going to seem like it makes it worse. And I want to multiply in by 1, multiplying in 1 over x squared, and just distributing that in. When we do that, what's going to happen, we end up getting just 1 in the numerator. 1 over x squared times x to the fourth, that's x squared. This just becomes minus 6, and we're going to have 25 over x squared. But now this denominator, I can factor it, really just focusing on this and this. Because we know, let's see, if I take x minus 5 over x, and we just square it, we're going to get x squared plus 25x squared. So we get back the stuff we wanted. But then for the middle terms, we're going to get minus 5, or minus 10. So in order to get it to be the same thing as our denominator, I can just add plus 4 on both sides, plus 4 here, so this is just minus 6. And then we can rewrite it. We can go from minus infinity to infinity dx, and now our denominator is all this stuff here. And now in some ways the integrals might seem worse, but what we can actually do is on this thing, in this form here, we can use Glasser's master theorem on it. Okay, now for our formula, we have this thing over here to the right. Now this is definitely not the whole theorem. Like there's a different version where we have like a summation in here that's a little more complicated. And also even with this formula, you could have Cauchy principal value on it, but that's only needed when you don't have the convergence, and then you can use Cauchy's principal value to extend it to non-convergent integrals. But that's not going to be necessary when we have convergent integrals. We can just drop the Cauchy principal value and just use the formula as we have it here. I did derive this formula in a previous video, so I'll provide a link in the description. You can check that out if you want to see how we go from here to here. But getting back to our integral, we clearly have something in this form here. We're going from minus infinity to infinity. We've got the x minus a over x, where the a value is going to be equal 5. So it meets this. It's definitely greater than 0. So we can take this thing and kind of go from here to here, and then it just becomes this f of x is going to simplify it a lot. So this is just going to become dx over x squared plus 4. But this thing here, this is just the arctan formula. We can think of this here as 2 squared. And so using the formula on that, we're going to have just 1 over 2 arctan x over 2, evaluated from minus infinity to infinity. We'll have the 1/2 in front, plug in infinity. Arctan at infinity is going to be pi over 2 minus arctan at minus infinity is going to be minus pi over 2. But then minus times minus is plus. Add these up, this is going to be pi. Putting it together, for my final solution, we just get pi over 2, and that's it. Okay, there you go. Thanks everyone for watching. Have a good day.